So supposing, consider 1-to-1 Tx between omega x to omega y. Now I can put the arrow both ways, that is, i.e. I have y equal to g of x and I have x equal to h of y. I have both functions. This could be increasing or decreasing. An increasing transformation is something like this, 1-to-1 transformation, e.g., right, this is y, let me say this is omega x. Of course, you can draw, you can consider omega x to be the union of two disjoint intervals, that also is fine, right. If you get, it's just that it has to be in the omega x that you take, it should be 1-to-1. Outside, if it's not 1-to-1, I don't care, that is, if it goes, if it does something like this, for example, even y equal to x squared is 1-to-1 if x is positive, is what I mean, right. So supposing this way, then the formula reduces because there is only one root. In a 1-to-1 transformation, if you pick any y in omega y, there is only one value of x where that could have come from, and therefore you can immediately write fy of y is fx of h of y into mod h prime of y. This can be straight away written down without any, if you know the other old formula, I can immediately write down this. Why can I write down this immediately? Fx of x is evaluated at h of y, there is no problem here, there is only one root. Why do I get this? 1 by mod g of x, or rather 1 by g of x is equal to h of y. G of x and h of y are reciprocals, always reciprocals of each other when you have invertible transformations, because the one quantity is dx by dy and the other quantity is dy by dx at the same point. So obviously they have to be reciprocals. If dx by dy is negative, dy by dx also will be negative. That is, if you have a decreasing transformation from going from x to y, or again you have a decreasing transformation going from y to x. Remember, this is an increasing transformation from x to y. It will also, if you plot it the other way, it will also be an increasing transformation from y to x. As y increases, x will increase, right. It's obvious. If you go from here to here, y is increasing, x is increasing. If you do it the other way, both will be decreasing. So this mod takes care of the mod of g of x in the denominator, g prime of x in the denominator. So this very simple formula allows us to apply or to find the PDF for very important case, which is the affine or linear, okay, let us call it linear transformation. The most important 1-to-1 transformation is the linear transformation. What is a linear transformation? Y equal to x plus b, including, I mean, I am including obviously the b, which is very important in our application, but so some of you might say no, that is not linear, strictly linear, but it is okay, we will call it linear, right. So e.g. if I do y equal to ax, I write in terms of random variables, but okay, which means basically you are doing, so if a is not 0. If a is 0, it is not a transfer, it is a constant, right. So by that means if y is equal to b with probability 1, and so the y is not a random variable anymore in the strict sense of the word, but I mean it is a very degenerate random variable. Any random variable which takes the same value is actually a constant, right? So you do not have to worry about that here. Okay, so a is not 0. So what is the relationship now? What is h of y? So this means that small x, if I write, will be small y minus b divided by a. This is the h of y. What does this transformation do? So okay, before that let us write apply this to here. What do we get? So what is Fi of, what is the output density? Output PDF is Fx of y minus b divided by a. There is no sign, I mean there is right, no mod here, but the mod sign will come here. So what will it be here? 1 by mod 1 by a. Okay, typically for positive A, this is very just 1 by A. This allows you to go back and forth between what kinds of things. The most important transformation here, which a sub case of this, is going back and forth between arbitrary m, arbitrary sigma squared, and 0 1 for the Gaussian case. So if I say E.g., I can go, I can assume either is the input and the other one is the output, right? Not necessarily always that it should be x input and y output. Y can be the input, x can be the output also. So if I want to go from 0 1 to some other m comma sigma squared, okay. So this, let me, before I get to that, this is a shape preserving transformation. What do I mean by that? What is the shape of Fy compared to the shape of Fx? It's exactly the same except for scaling and shifting. So this is just scaling and shifting. There is no other change to the shape as such. And flipping, of course, there is also flipping if A is negative. So assuming that A is greater than 0, for A greater than 0, it is just scaling, shifting and scaling and shifting. If A is negative, then there is a shift, but let us just for our understanding, just assume A is positive. So the Gaussian case, now coming to that, supposing x is n0 1 and we want y to be n m comma sigma squared, right? What should you choose A and B to be? This is, so if a Gaussian transformation is the input, any amount of scaling and shifting will only give you another Gaussian output, but it will have a different m and different sigma. So if you want this, from this you want to go here, what should you do? Tell me. What should be A, what should be B? Think about it and tell me. A equal to sigma, right, and B equal to m, correct. So the desired transformation is y equal to sigma x plus m. Go back and think about this. This is not sigma squared, it's only sigma. The more the sigma, the more the spread of y, and that 1 by sigma will come in the PDF of y outside the exponential. Where does that, go back and check the formula for the Gaussian PDF. You get 1 by sigma, sigma root 2 pi. 1 by sigma comes directly in the outside, right? Isn't it? And this m is comes same as, right, comes exactly as it is here. Let me put it here. Say we want this, then the desired transformation is this. So this y minus b, y minus m by sigma in the exponent is exactly what is there in Fy. So you start with e power minus x squared by 2, just that, and you go to e power minus y minus m whole squared by 2 sigma squared, right? So I think it should be obvious. You just look at it for a minute, you will see this, no issue at all. Okay, so you can go back and forth. Supposing you start with some y, which has some arbitrary sigma and some arbitrary m, you want to get an n01 out of it. All you have to do is remove the mean y minus m and divide, normalize by sigma. So to go in reverse, you do this. Both are important in practice. Right? Okay, so this shows how both shifting and scaling comes, but in some other cases, like for example the exponential and so on, you may not want to shift, you may only want to scale. Same principle. You can always have b equal to 0, right. So, I leave you to think about it. What happens if you take the 0 exponential Rayleigh, all those periods, they start from 0, right. So, if you want to preserve that, you should not shift, you should only scale. You can always get more width or less width depending on the value of sigma, sorry not sigma, a, and you want to keep a greater than 0 to maintain polarity. If you take a, if you want to have a negative right exponential or flipped version, then you must take a to be negative, it is not right. If you take a to be positive, it will only keep it positive in, will give you positive out. Okay. So, I think it is simple enough that I do not want to spend more time on this linear transformation. Does anyone have a problem with this or a question? Okay. So, what about y equal to 1 by x? Okay, going away from this. So, what I am going to do is maybe I will erase this. Can earlier when I started this whole discussion, I said y equal to 1 by x can land you in trouble if you take x to be some discrete random variable with finite probability of taking the value 0, right. If you like, for example, Bernoulli or something, because 1 by x has undefined value when x is 0, and you do not want right an undefined value to have finite probability, right, as simple as that. But it turns out you can do a 1 by x transformation perfectly you can do it is a perfectly healthy transformation when x is continuous, for even when it includes the value 0, like for example x is 0 u 0 1. So, if I do that, by the time I erase this, you should tell me the answer. The reciprocal, what is the answer? Is this does this qualify as a one to one transformation? What is omega y? I am only looking at this interval 0 to 1 now, only 0 to 1. Hmm? 1 to infinity, right. Omega y is 1 to infinity. What is the PDF again? Very simple. Just what happens if you apply this formula? This is constant. I don't even have to worry about this part because this is fx is constant. What is this? So, the minus will go away when you take the mod. So, this is an example of a decreasing transformation without worrying about the value of a or anything, right. So, by itself is decreasing for that interval. If you take x to be some negative portion, then right then it is an increasing, then even then it is decreasing anyway. So, you can also try this, right. It will the fact that the transformation is a big jump from minus infinity to infinity, if you include a two-sided swing, will not change the result will not change the method. So, you can apply call this a one-to-one transformation even if x is, let us say, varying between -1 and 1 or whatever, it is perfectly doable. But in this particular case, for x is u 0 1, you get fy to be 1 by y squared for y greater than equal to 1. So, y takes unbounded values and I do not care about infinity. Basically, I do not care at all about x taking the value 0 because it happens to 0 probability in the limit, and therefore, y will only take infinitely large values in some right in with 0 probability again, and this is a perfectly healthy PDF.